significant digits, also known as SDs, sometimes significant figures. So what is this? Well, in science, unless we're counting, like we're counting 4 apples or 10 mangoes, or there's an exact number as part of a formula, like the half in a half mv squared, then the numbers we deal with are measurements. And there's always a limit to how precise a measurement can be. By precise, we mean the exactness of a measurement. The concept of some digits being significant while others are not helps us keep track of this precision. Any measurement you make is only as precise or as good as the tool you're using to do that measurement. And any measurement will contain digits you know for certain, plus one digit that you're estimating. Let's look at these two rulers. They're measuring the same thing. Okay, they're measuring some object that goes up to this blue line here. But with this first ruler, you can see that you have 2, say, centimeters, 2.1, 2.2, 2.3, 2.4, 2.5 centimeters you know for certain. And then you kind of estimate this last digit. You say, well, this is half of a millimeter. So we'll say this measurement is 2.55 centimeters. The 2.5 is certain using this ruler, but the 5 at the end is an estimate. If we were using the ruler on the bottom, we have 1, 2, and nothing here is certain. We don't know if this is 2.5 centimeters or 2.4 or 2.6. So we're just guessing at this point, or estimating at this point. So we're estimating 2.5 centimeters. One of the digits is certain, the 2. For sure our measurement went past this 2 mark. But then when we said it's 2.5, we were estimating that 0.5. So with a ruler on the bottom, you might say that that object is 2.5 centimeters. With a ruler on the top, you might say it's 2.55 centimeters, one more digit than the bottom. What would not make sense is having a measurement of 2.553. You can't get to this precise level because only the 2.5 portion is certain using ruler A. The significant digits in a measurement are the certain digits plus the one estimated digit. So we would say that ruler A, that 2.55 measurement, we would say it has 3 significant digits, the 2 certain ones and the 3rd estimated one, whereas the ruler on the bottom has 2 significant digits, this estimated one and the 0.5. Okay, why don't you give it a shot? How many significant digits would you say there are for each diagram? So for A here, we're reading pressure, and I can see this arrow goes beyond 4, beyond 4.1 to 3. So I know for certain we're beyond 4.3, and I would estimate this point in between. I can say, well, that's maybe 4.33. So my measurement that I would write down would be 4.33. That's 1, 2, 3 significant digits. If I use this ruler to measure this block below, I can say that I go beyond the 1 centimeter mark. I certainly go beyond 1.1 and 1.2. So 1.2 is a certain measurement, and I estimate that last bit to be a half. So I'll estimate the total measurement to be 1.25 centimeters. Therefore, I have 1, 2, 3 significant digits. Okay, so let's look at some rules for counting significant digits. I'll read out the rules and then go through some examples. So, rule number 1, all non-zero digits are significant. So you see any number 1 through 9, count those as significant digits. For example, the number 237 has 1, 2, 3 significant digits. These are all not 0, therefore they're all significant. 1, 2, 3 significant digits. 1.897, there's no zeros here, so we can count all these digits as significant. 1, 2, 3, 4 significant digits. Middle zeros, zeros that are in between the non-zero numbers, and in Alberta, trailing zeros, those are zeros that appear after all the non-zero numbers. Those are significant. Examples. These are middle zeros, so we count them as significant. Middle zero, we count as significant. Trailing zeros, we count those as significant. Trailing zeros, we count those as significant. So, first number, 1, 2, 3, 4, 5 significant digits. 5.02, 1, 2, 3 significant digits. 6,200, 1, 2, 3, 4 significant digits. And 19.000, 1, 2, 3, 4, 5 significant digits. Whereas middle or trailing zeros we treat as significant, leading zeros, those are zeros that are in front of all the non-zero numbers, are not significant. Examples. These zeros are all leading. They are before you hit any number that isn't a 0. All these are leading zeros. Leading zeros. The 2 zeros at the end are trailing, though. Okay. 0.008, we don't count any of the leading zeros as significant, so only the 8 here is significant. So this number has 1 significant digit. 0.000416, these leading zeros do not count. So 4, 1, and 6 are significant. That's 3 significant digits. And in the last number, 0.01200, the leading zeros are not significant. The trailing zeros are, so 1, 2, 3, 4 significant digits. Finally, exact numbers, we say have an infinite amount of significant digits. Exact numbers would include integers obtained by counting objects or integers from definitions. What we mean by that is if we counted 4 objects, then the number 4 has an infinite number of significant digits. So we can kind of think of it as 4.00000000. It's exactly 4. Or 1 foot is defined to contain 12 inches. So the number 12, when you're converting feet to inches, would also be considered to have infinitely many significant digits. One note on trailing zeros. Trailing zeros can be ambiguous. For instance, the number 700. We don't know if that is, we don't really know, are we dealing with exactly 700 or something on the order of 700. But for Alberta, the province of Alberta, when you take your diploma exams, we treat trailing zeros as significant. But if you want to be sure of how to treat them, the best practice is to write a number using scientific notation. Okay, your turn here. Pause the video and see if you can figure out how many significant digits are in each of those numbers. Okay, let's look at the answers. For 5.87, that's 1, 2, 3 significant digits. 0.031, leading zeros don't count, so just 1, 2 significant digits. 52.90, 1, 2, 3, 4 significant digits, trailing zeros count. 00.2001, the middle zeros count, the leading zeros do not, so this is 1, 2, 3, 4 significant digits. 500, 1, 2, 3 significant digits, and 6 atoms, we're counting 6 atoms, so we say that has an infinite, this is the symbol for infinity, infinite number of significant digits. Now let's look at how to use significant digits when we calculate numbers. Like how do we keep track of the digits that are significant so that we can keep track of the proper precision of our calculations. Basically, how many decimal places do we round to? So first off, how do we round? Well, our rule is if the number immediately to the right of the last significant digit is less than 5, then you keep your number the same. The value of the last significant digit remains the same. If that number is greater or equal to 5, then you round the last significant digit up. Example, 207.518. If we rounded that to 4 significant digits, let's count the significant digits from the left to the right. 1, 2, 3, 4 significant digits. So the last significant digit is this 5. What we'll do is we look to the right, and to the right is this number 1. 1 is less than 5, so we keep the 207.5 the same. So 207.581 to 1, 2, 3, 4 significant digits is 207.5 meters. If we were rounding that number to 3 significant digits, well then 1, 2, 3 significant digits means your last significant digit is a 7. We look to the right of that, it's a 5, so we need to round this last significant digit up to 8. So round it to 3 significant digits, this number becomes 208. If we were rounding 207.518 to only 2 significant digits, then the 0 here would be your last significant digit. You look to the right, and you're going to need to round up. But the problem is you can't write the number 210 using only 2 digits, sorry. So in this case, you will need to use scientific notation. So we want to have 210, but we're only using 2 significant digits, so we need to use 2.1 times 100, or 2.1 times 10 to the power of 2. And that would be the same story if we were rounding to 1 significant digit. To 1 significant digit, then that's your last significant digit is the 2. We look to the right, that number is less than 5, so we keep the 2 the same. But how do we write 200 using 1 digit? We need scientific notation, so this would be 2 times 10 to the power of 2. Now, what if you're not just rounding a final answer, you are doing calculations? Well, we have different rules for this. So with multiplication and division, the rule is you would count the number of significant digits in each number that you're multiplying or dividing, and then the number of significant digits in your final answer is the lowest number of significant digits of each number in the calculation. What do we mean by this? Let's take this first example. 38.65 times 105.93 equals 4,094.1954. And I'm saying we should round this to only 4,094. Why? Well, we count the significant digits in the 38.65. 1, 2, 3, 4 significant digits. 105.93 has 1, 2, 3, 4, 5 significant digits. So I look between these two numbers, the numbers I'm multiplying or dividing, and I say the number that has the least amount of significant digits, the 4, that's how many I'm going to round to. So my final answer should have 4 significant digits in it. So I round 4,094.1954 to 4 significant digits, so I round it to 4,094. The second example, again, count the significant digits in the numbers you're multiplying or dividing. So 23.096 has 5 significant digits, 90.300 also has 5, so my final answer should have 5 significant digits. In my calculator, I get this number. I count 1, 2, 3, 4, 5 significant digits. I look to the right. This number is greater than 5, so the last significant digit I need to round up. So I need to round that up to 2085.6. In the last example, we have 125 times 9.000. In the calculator, that will spit out 1,125. But if we count significant digits in the numbers we're multiplying, there's only 3 significant digits in 125, so our final answer should only have 1, 2, 3 significant digits. So we should round this to 1,130, but we need to write that using scientific notation. So that would be 1.13 times 10 to the power of 3. Because that's the only way we can write 1,130 using only 1, 2, 3 significant digits. Now let's look at addition and subtraction. For addition and subtraction, you don't go by the number of significant digits that are in the numbers you're adding or subtracting. You go by the number of decimal places that you're using in those numbers. So you want to limit the final answer to the least number of decimal places in any of the numbers used in the calculation. Let's look at an example. If I was adding 1.2 plus 4.41, which equals 6.61, I would round that answer to 6.6, just 2 significant digits. Why? Because I look to that first number, there's only one decimal place. So I go by the least number of decimal places. There's 1 decimal in the first number, there's 2 in the second number, so I round to 1 decimal place, or 6.6. 77.2 plus 10.46, again, there's 1 decimal place here in this number, 2 decimal places in the bottom number. I will limit my final answer to just 1 decimal place. So I round 87.66 to 87.7. And then looking at this subtraction, we have 1 decimal place for the 255.0, no decimal places for 99. So I would round my final answer to just 156. I wouldn't have any decimal places because 99 doesn't have any decimal places. If you're doing multiple calculations all at once, or questions that go step by step by step, and you have intermediate results, so results that you're going to use in another calculation, you want to be careful with that. What you want to do is, with intermediate calculations, keep as many digits as you can and carry that number into the next calculation. And if you can't store that many digits, then round that result to retain at least 1 more digit that you would otherwise round to. Okay, but basically, if you're doing a whole bunch of different calculations, then what you want to do is keep as many digits as you can in your intermediate calculations, and then round the final answer to the correct number of significant digits at the end. Okay, to sum this up, for rounding, if the number immediately to the right of the last significant digit is less than 5, keep that last significant digit the same. If it's greater than or equal to 5, round that last significant digit up. For multiplication and division, the final answer should have the same number of significant digits as there are in the number with the fewest significant digits. And for addition and subtraction, the final answer should have the same number of decimal places as the term with the fewest decimal places. In the back of the book, of your textbook, there's more information on significant digits. You can copy this link on the bottom as well if you want to learn more about significant digits, how to calculate them, how to use them. Thanks. And if this is all a little bit fuzzy for now, don't worry about it so much. As we go through the physics unit and we do a lot of calculations, we'll take a look at how to round answers properly according to the significant digit rules. So I want you to get a baseline understanding now, but as we do it in practice, when we do more calculations, you're going to start getting more used to it.